Hello students, this video is on section 2.5, subtracting fractions. The good news about subtracting fractions is if you're able to add fractions and you know the different processes for different types of fractions, subtracting is the same. Okay, so we'll start how we started with addition, which is when denominators are the same, meaning that the pieces that we're talking about are the same size. Because these are so similar, I'll do a few examples of each, and that's about it. So the first example we can talk about is 3/5 minus 1/5. Okay, just like with addition, when the denominators are the same, we're talking about the same size pieces, and so it's easier to compare and compute with fractions. So for a diagram, this could look like this. And 3/5 are shaded, and then I'm taking 1/5 away, which is essentially like unshading 1/5. Okay, so when I take that 1/5 away, we can look and see the size of my pieces have not changed, so it's still out of 5, but how many are shaded now? There's 2. Okay, hopefully you remember this process from adding. If the bottoms are the same size, we simply do the operation with the numerators and keep the same denominator. Okay? Another example would be like this: 9/10 minus 2/10. Because we're comparing pieces that are the same size, we do 9 minus 2, and we know that we would have 7/10 left. Okay? However, we also know that we can encounter fractions where we're not talking about the same size pieces, and what that would look like on a fraction is having different denominators. In that case, what we need to do is find fractions that are equivalent, that do have the same denominators, and then use those to do the computation. So 13 out of 20 minus 1/6. Okay, 13 out of 20 minus 1/6. 20 and 6 are the denominators that we're looking at, but we can't do this as it is because they are not the same denominator. So what we need is we need to find a common denominator for these fractions, and to do that the long way, if you're not comfortable looking and telling what it is, you want to find the least common multiple using the process we've talked about to find the least common multiple of the denominators, 20 and 6. In this case, it's 60. And what we need to do is say, how did I go from 6 to 60? I multiply by 10. Okay? So therefore, I'll do the same thing here. Times 10, and we get 10. How did I go from 20 to 60? From 20 to 60, I multiply by 3. And we'll do the same thing on the top. 13 times 3 is 39. So I have 39/60 minus 10/60. 39 minus 10 is 29. And my size of my piece doesn't change, so it's out of 60. This cannot be reduced, but if it could, that's expected of you at this point, since we talked about equivalent fractions. Okay? Another example, 5/6 minus 3/7. 5/6 minus 3/7. 6 and 7 are not the same, so we need to make them the same. 6 and 7, the least common multiple is 42. Okay, how did I go from 6 to 42? I multiply by 7, so I must do the same thing to the numerator in order for this fraction to still be mathematically equivalent. Times 7 is 35. From 7 to 42, I multiply by 6. So I do the same on the top. 3 times 6 is 18. So we now have 35 40-seconds minus 18 40-seconds. And when we do that subtraction, we get 17, 40-seconds. Okay? If you're getting anything other than these, or if you're not sure where I'm getting any of this work from, make a note in your notes so we can talk about it during class, please. So those are the two probably common types that you'll see with fractions, with like denominators and with unlike denominators. However, we also know that we talked about mixed numbers. And just like in addition of mixed numbers, we sometimes had to carry. In this one, we sometimes have to borrow. So let me show you what that looks like, because you need to work these very carefully. If we have 5 and 7/12, and we're subtracting 2 and 1/6. Okay, just like if we were doing a regular subtraction problem, like 22 minus 13. Where do I start with this? I always start on the right. I don't do 2 minus 1 first. I do this first. And if this number is smaller, I know I need to borrow. But keep in mind that we always do the right first when we're adding and subtracting. So 12 and 6 are not the same, but I can make them the same fairly easily. If I multiply this by 2 and this by 2, I'll get 12 in the denominator. So I'll have 5 and 7/12 minus 2. The whole number stays the same. We're not changing that. And 2 over 12. Okay? And we always start on the right, so we're going to start with the fractions. 7/12 minus 2/12 is 5/12. 5 minus 2 is 3. Okay? So that's the most basic form of a mixed number subtraction. We had to change the denominators but not borrow or anything like that. There are other ones that are simple as well with mixed numbers. For example, if we have a mixed number and we subtract a whole number, we don't have a lot of work to do, because since we start on the right, 1/3 minus nothing is 1/3, and 6 minus 2 is 4. So if we have a mixed number minus a whole number, that's an easy problem as well. We're just looking at the whole numbers because the mixed number, the fraction part's not taking anything away. Okay. On the opposite end of that, however, is if we have a whole number and we're subtracting a mixed number. Then we'll have to borrow, and I'll show you what that looks like. If we have 10 minus 1 and 1/3. Okay? Now we don't have anything here, so we can't do nothing minus 1/3. So what we need to do is borrow. Our whole number 10 becomes a 9. And I'm going to put one whole here. However, I don't want it to look like 1 because that won't help us subtract. So if I do a fraction with a denominator of 3, because I need that anyway in order to do this subtraction, what will the numerator be in order to reach one whole? Well, if I have 3 parts, how many of the 3 parts do I need to take the whole thing? I need to take all 3. So I've converted 10 into 9 and 3/3. And that's mathematically equivalent because that's 9 and 1. 9 and 1 is 10. Okay, now I can do my subtraction, but this is what borrowing looks like. Okay, 3/3 minus 1/3 is 2/3, and 9 minus 1 is 8. 8 and 2/3 is our answer. I'm going to do one more, and it's a long one, but this is about as difficult as they get. So follow along with each step. And anything you're not understanding, please make a note. Okay, 5 1/3 minus 2 3/4. There's lots going on here. The first thing that I know is that the denominators are not the same. So that's the first thing I need to deal with. 3 and 4, the least common multiple of those is 12. So this becomes 5. If this is 12, that means I multiply by 4, so I have to do the same thing here. So I get 5 4/12. And then here, remember the whole number stays the same, but for the fraction, to get 12 on the bottom, I multiply by 3. So I get 12, and then I multiply by 3 on the top to get 9. So I fixed our first problem. Our first problem was that the denominators weren't the same. But now you might be able to see that we have another problem, and that is that I can't take 9 away from 4, so I'll need to borrow. Remember, when we're borrowing, we have to add 1 to this. If my denominator is 12, to take a whole thing that's cut into 12 pieces, I need to take all 12 pieces. So I've taken 1 away from the whole number and I'm adding 1 to the fraction, but I'm not done because this is too complex. There's too much going on here. I need to clean it up a little bit. So again, we switch this. This is now 4 because we borrowed from it, and I have 4 12ths and 12 12ths, which is 16 12ths. Okay, this one hasn't needed to change in this round because it's just what we're subtracting. So it's minus 2 and 9 12ths. Finally, we can do this. 16 minus 9 gives 7. And it's still over 12 because we haven't changed the piece. And 4 minus 2 is 2. So all the way back from 5 1/3 minus 3 2/4, 2 3/4, we had to switch several things. We had to make the denominators the same. We had to borrow. And then we finally could do the subtraction. This is the most complicated that you'll see, okay? When you're subtracting mixed numbers. If any of you have any questions, please make notes so that we can talk about it in class because I'm sure you're not the only one. Okay?